project for cohort 244. I decided to go with object-oriented programming project that involves using chess. Didn't entirely finish it, but here's a little small demonstration. So here's my chessboard on the left side. I was going to implement a API function to play against a computer, but I only had time to just move the individual pieces myself. So we're going to play against friend. Here to the right, I have Angular debugging tools. So as I select different pieces, you will see it change, used for debugging purposes. So let's get started off. So here, for example, I can pick one of these pieces and it tells me where it is safe to move this piece. So let's move it there. It updates over here. So as you can see, my chessboard is completely updated. I can see here different properties within my application. If I select one of these pieces, it updates it again. And then here you can see player 1, which is black player. And then the safe squares, which would be the safe squares for this piece. And yeah, pretty much that's it for my project. I didn't complete any of the other functionalities of chess. It's just way too complicated. I don't know how to play chess. So that would be something I would have to implement, and I would really want to if I had another 20 hours. But yeah, as you can see, it's working. But of course, there's more complexity to chess. Unfortunately, I did not have the time to implement everything I wanted to. This is my project. I ended up deciding to do my project in Angular. I have experience with Angular, and I decided to just do it so I can get some more practice on it. As you can see, it's also in TypeScript. So TypeScript is just superset of JavaScript, and it's eventually transpiled into JavaScript for browser implementation. So there's a lot of static typing where you can define like types for objects and properties and whatnot, and the interfaces, which are just a bunch of blueprints for objects. So yeah, I'm gonna go over mainly 3 files that are very vital and important to my application. So here is the first one. Here is my first file that I will be sharing, and as you can see here, I'm using structural directives ng4 to ng4, so it's just a for loop within a for loop, just to render all my pieces and squares. Depending on is square dark or the squares will either be black or blue. Once a piece is selected, I will call this, or clicked, I will call this or invoke this method called move. And that piece is, as you can see over here, once I call move, I'm calling 2 methods, which are selecting piece and placing piece, and passing these parameters of x and y, which are the coordinates where I clicked. So for the first one, selecting piece, just doing some preliminary checks for the pieces, so making sure the space isn't empty and making sure that the player that is playing isn't selecting a piece that they're not supposed to be selecting. And then after that, if you click on the same square, just doing some debugging, so it just kind of unselects the piece that we selected. And then here we have a property called selected squares, where we create this object that has piece and then our x and y coordinates for that selected square that we will be using later. And this is important. This right here, we are getting the safe squares for the corresponding instance of the piece that we selected. To my save squares function, I did want to show how I was able to render my chessboard. So here's kind of a visual view of what I did. So I have this object called chessboard. It's an array within an array, and each array, as you can see here, it contains rook, knight, etc., and then all the empty pieces are just null. So I have these classes called rook, knight, king, and each of them are unique, as in they have their own directions that you can go. So as you can see, I'm using a kind of a grid system to map everything. So as for example, let's pick something more easier. Yeah, I guess we can use spawn. We can go x1 or up 1 and at the same spot, or up 2, up 1, right 1. These are just kind of like basic directions in which pawn can move. And then also telling it what color as well. We're setting the color here because each piece extends to this piece class, and each piece class has this fan character, which is the representation of what each character or each piece represents. So PKQ, uppercase. So if it's uppercase, I believe it's black, and if it's lowercase, it's white. And then the direction, and then the color. And yeah, if we go back to our chessboard view, that's just kind of how the basic layout is set for my chessboard. Later, we were going to go and check our find save squares method. In this save square method, we are pretty much looping through the whole chessboard and getting the save squares for all of the pieces. And we are putting them in this save squares map that contains strings, which is our keys, and then all of the coordinates for that specific string key. That string key is going to be our x and y value, which we're going to use for our key. So yeah, we're transversing through all of the squares, and then just kind of going through everything, making traversing through the whole chessboard, updating all the save squares depending on the piece. So each piece that's selected, as you remember, depending on the direction, that's where it's safe to move to that spot. And then just appending those new coordinates if the position is safe. And the way we're determining if the position is safe, we're just checking to make sure, simple stuff like if the square isn't outside of the chessboard, and then also making sure it's not going and overlapping other pieces that aren't our piece or the user's piece. And if it's not, then just restore the position and don't let it move. And then there's also different stuff for pawn, knight, and king. So it's just basically pushing it to piece safe squares through the array of our safe squares. But obviously, if it's not a king, a pawn, or a knight, or a knight, so a queen, rook, whatever, everything else. There's other stuff that we need to do for that, because for for example, queen, it doesn't just move up one spot or to the left or to the right. It can go diagonally across the chessboard, so we have to account for that. So that's why we use while, and then just keep incrementing it as we traverse the chessboard through the chessboard diagonal or across. So just keep updating it until we hit something that we're not supposed to be doing. So it's position safe after move. So if we hit like another piece that we're not supposed to, and then we're just storing it. Once we traverse through like a piece, we just save it into our new safe squares. Like I said, we're gonna have this key, which is our x and y coordinate, and then our p safe square. So we're just adding to it. And as you can remember from our other TypeScript file, we are trying to get, now we have this safe squares map, and we are using the get function, and we're using x plus y, x plus basically the key to get that safe spots for that certain key, and that key is determined by the piece we selected. So that piece we selected has a x and y coordinates, and we use that as a key, plug it in here, and then where we find that same x and y coordinate, which is our key, we will get all of its safe squares, and then that's how we get these dots. And then what I will talk about next is placing the piece. We're just doing some verification at first, so making sure that that piece is one of the pieces safe squares. Basically we just do like a so we're making sure that those keys of x and y are in our p safe square property. Once we verify all that is great, the selected square, we destructure it with previous x and previous y, and then we go to this move function, and then in our move function all we're doing is just checking and making sure that the piece color is correct, and it's associated with the current player's color. If not, return. And then also if it's in one of our safe squares for that piece. If we make sure and verify all of that is correct, we have this small implementation where pawn, king, and rook can only move once. I guess this is a chess move. That's as far as I went with like the complexity of chess and their rules. And then up here we're just updating the board. So previous x and previous y is our old square. We're going to leave that empty, and then update our new x and y with that piece that we selected. So we're just kind of updating the board, and after that we're just doing some small updating. So change the color of the player. So the player, if it was white, it's going to be black. If not, it's going to be white. And then finding all the safe squares for the newly updated chessboard. We're just updating our chessboard view, and then rendering it again with all the moved pieces, and then unmarking the selected safe squares for the previous selected piece. And that's pretty much for my code. Some small questions that you wanted me to answer was some of the easier features that I completed was probably the view of the chessboard. So I decided to go with a two-dimensional matrix of pieces. So using those SVG files, and that was one of the easier features of this app. Some of the features I struggled with was trying to implement the API. I wasn't able to implement it. I tried it, but there was just problems with the just representation of each piece in its square. We had to use some kind of Fen converter, and I just didn't have time for it. Um, the reason I decided to create this project, it was just one of the projects that Alexander gave us. I thought it was interesting because it was an Angular and I haven't touched Angular in a while. Plus, practicing my OOP skills, so that was really helpful with that. Um, Getting back into the groove. If I had 20 more hours, I would try to implement that API, but probably in a simpler, not chest, but more like checkers. See if that was a possibility of doing. Um, and then for debugging, I didn't use console a lot. It's very messy, so I use this Angular tool in Google Chrome extensions where it kind of presents you with your current state of the app. Don't know why it's not working now, but there we go. Yeah, so you can see here pieces of 6 squares. So that's one of them. So x2, 0, 1, 2, and then 0, 1, 2, 3, 4, 5. So it was really easy to debug and see the current state of my app. And you can see here a bunch of other stuff too. Yeah, so seeing my pieces. So if it's uppercase, it's black. If it's lowercase, it's white. So I can see like basically all of the state of my app, which is really super useful when debugging. What else? What are some ways you can improve your code base to make it easier to evaluate, test, and debug? Probably break it up into smaller components. There's a lot of methods I use, and there was definitely a lot of troubleshooting and debugging at first because there was stuff that was happening and I didn't know what was going on. So there was a lot of looking at and using Angular tools and seeing, okay, what's the current status of my application for this certain property. Um, so there's definitely always ways to improve your bug. This is not perfect by any means. There's different ways about going. Maybe I did it too complex. I could have done something more simpler and straightforward. But like I said, I just kind of built something that I thought as I went along was good enough or good. Um, and yeah, that's it for my project. It looks like I answered all your questions. If there's any further questions, feel free to message me. Thank you.